Hi, my name is Tristan, and today I'm going to be teaching two very important concepts from Unit 3 functions. In this unit, we learned about several important function topics, including identifying and evaluating functions, graphing functions, transformations, function operations, etc. Functions are important because they allow us to describe relationships between inputs and outputs and help us understand how changing input affects an output. For my two concepts today, I chose evaluating functions from category A and transformations of functions from category B. First, I'll demonstrate how to evaluate a function, then I'll explain how to identify transformations of a function. And I will be showing my work on another clip right below me or after this video. But let's start with evaluating functions. Concept 1, evaluating functions. Let's start with evaluating functions. My original example problem is given in function. My original example problem is this given function. F of x equals 3x to the power 2 minus 4x plus 2. And the goal is to find f of negative 2. The first thing that I need to do is substitute negative 2 everywhere I see an x. So the first thing I write is f of negative 2 equals 3, so replace the x, of negative 2 to the power of 2 minus 4 times negative 2 plus 2. Now I use the order of operations. First, negative 2 squared equals 4. So I have 3 times negative 4 equals 4 times negative 2 plus 2. After this, I multiply. That leaves me with 12 plus 8 plus 2. Finally, I add everything together. 12 plus 8 plus 2 equals 22. Therefore, f of negative 2 equals 22. The important thing to remember when evaluating a function is to replace a variable with the given input value and then simplify carefully using the order of operations. Now that we've gone with that concept, let's move on to my second one. Concept 2, transformations of functions. My second concept is transformations of functions. My original example problem is to describe the transformations of the parent function, f of x equals x to the power of 2, to create the function g of x equals 2 times x minus 3 to the power of 2 plus 4. I'll compare this function to the parent function f of x equals x squared, but first I have to look inside the parentheses. I have x minus 3 inside the parentheses, and because it is x minus 3, the graph shifts 3 units to the right. Next, I look at the numbers outside the parentheses. There is a 2 multiplying the squared expression. This basically means the graph has a vertical stretch by a factor of 2. Finally, I look at the number at the end. The function has plus 4, which basically says that the graph shifts 4 units to the top, or upward. So the 3 transformations are the first shift to the right side, 3 units. The second shift is vertically by a factor of 2. The third one is up 4 units. The original parent function y equals x squared has its vertex at 0, 0. After shifting right 3 and up 4, the new vertex is 3, 4. Therefore, their transformations are right 3, vertical stretch by 2, and up by 4. And the new vertex is 3, 4. The important thing to remember is that changes inside the parentheses affect their horizontal position, while changes outside the function affect the vertical position and shape. Conclusion. To summarize today, I demonstrated two concepts from Unit 3. First, I showed how to evaluate a function by submitting an input and simplifying. Second, I showed how to identify transformations by comparing a function to its parent function. These concepts are important because they help us understand how functions work and how their graphs change. Thank you for watching.